So here's our last relative motion problem. It's a very typical problem. You have two cars. Car A is going at 60 degrees from X, and car B is going straight down in Y. But car B happens to also be traveling in an arc, and so there will be a normal acceleration. And so we're given everything for car A. It's going 18 meters per second down to the left, but it's decelerating at 2 meters per second squared up to the right. Car B, so it's slowing down as it sees car B merging onto the freeway. Car B is coming straight down at 12 meters per second, but happens to be still coming off this arc with a 100-meter radius. Car B sees car A coming and therefore is accelerating at 3 meters per second squared. And so they want to know B relative to A. So again, the appropriate equation is B equals A plus B relative to A. If it had asked for what's A relative to B, you would have had to have used A equals B plus A relative to B. And so here you can see I've written in vector form what you need to do. The velocity of B is 12 down, and velocity of A is going down to the left at 60 degrees. This is complicated enough that I went ahead and immediately just changed everything into their I and J components. So 12 down is minus 12J. And so I hope you can see that 18 going down and to the left is going to be 18 cosine 60 going to the left in the x, so it's a negative 18 cosine 60. And then it's also 18 sine 60 going down, so that also is negative in the j. And then you just solve for v, b relative to a. The acceleration is very similar. You're given that car A is decelerating, so going up to the right at 2 meters per second squared, and at 60 degrees along that road. B is accelerating down 3 meters per second squared, but it's also going in a circle, so it has this centripetal acceleration of v squared over rho. And that always goes to the inside of the curve, which in this case is directly left. If you look at the picture, v was 12 and the radius was 100. So this is the acceleration. And so I just wrote that out in picture form here. Then I went ahead and put that into I and J components here. Clearly 3 down is minus 3J. 1.44 left is minus 1.44I. Up and to the right at 60 degrees is cosine 60 for the I and sine 60 for the J. And these are both positive. It's going to the right and up. So those are those two. And then you just solve for A, B relative to A.